Oh, it's cold out. Oh, hey, Dr. Romano, it's cold outside. I just came inside to get warmed up. What you got on the board there today?
Hi, I'd like to go over a problem with you. This is a hard problem. It's a challenging problem. What I want you to do is to compare the pKb's of these two compounds. Before we start, keep in mind amines are bases. And if you're a base, that means you want to capture a proton or an H+. That's the concept. Now, I give you these two compounds, okay? And I ask you, how are they comparing pKb? Remember, a small pKb means that it's going to be the one that is more basic. So if I say to you, which has the smaller pKb, I'm asking you which is more basic. First of all, if we look at this problem right here, the minute you see nitro groups, that's going to steal the electron density away. So in other words, if you look, the nitrogen wants to capture an H+. This is stealing, this is stealing, and this is stealing. So that means that these electrons are not going to be localized very well because inductively they're being withdrawn into the ring. Also, as you know, we would have resonance here. So there's two things against us here. We have induction, all right, induction, and we have resonance. Now let's look at this one. Well, the same idea. What do we want to do? We want to use these electrons to capture an H+. That's what we mean by basic. Once again, you got the three nitro groups, so that means you're going to have induction. So that's not good. That's stealing the electron density away from the nitrogen. How about resonance, though? This is where it gets very difficult. Is there resonance here with the nitrogen in the ring? Notice that this group is awful big. It's going to hit this nitrogen from this side and this side. So that means it's going to be in a different plane. So therefore, resonance is not going to be the problem. Because it's in a different plane, that means that those dots, these electrons, would more readily accept a proton. Another way to say it is the compound here has the smaller pKb, meaning it would be more basic. We call this the steric inhibition of resonance. Because it is clash, that means they're in a different plane. So if they're in a different plane, then that means that you're not going to have delocalization. So the first compound, to rehash, first compound had resonance and induction, and therefore those electrons are not localized on the nitrogen at all. They are being withdrawn. The second example, we have induction, but there's no resonance with the nitrogen simply because of steric effects. It pushes it into a different plane. Very difficult problem, but it makes you think. But always remember, if you see an amine, they're bases. And they might be weaker bases if they're aromatic.
Okay, Dr. Romano, if I see amine, think base?
Think base, and you'll thank me. Good day.
Okay, Dr. Romano, thank you for another great problem. Have a good day, sir.